So carbon nanotubes work great around Earth, but they are totally inadequate for black holes. For black holes, the critical material science property you need for this rope is the tensile strength to mass per unit length ratio. It needs to be strong, high tensile strength, but low weight, like light, low mass per unit length. And that's the critical ratio. In fact, what I showed in my paper is that you need a tensile strength to weight ratio that is as strong as is consistent with the laws of nature. So in fact, the laws of nature bound this quantity. The finiteness of the speed of light means you cannot have an arbitrarily strong rope with a given mass per unit length. There is a bound set by the c squared in some units that bounds the maximum possible tensile strength that any rope can have. Any rope, in fact, that has that, or an example of a rope that has that is a string. So a string is, a fundamental string from string theory is an example of a hypothetical rope that is just strong enough to saturate that bound, that strength bound. And then the problem is the following. The problem is that if you have a rope that saturates the bound as strong as any rope can be, it is just strong enough to support all of its own weight.